Good morning, everybody. Welcome to Diploma Online class. The subject name is Analog Communication Unit 4 Antenna and Wave Propagation. Now, table of content. The first one is Fundamental Law of Electromagnetic Wave. Here, I will try to cover what is electromagnetic wave and also what are the fundamentals are there in this electromagnetic wave. Next, I will try to cover what is electromagnetic spectrum. Then after, I will try to cover what are the application of electromagnetic spectrum. After that, I will go to explain what are the different types of wave propagation that are used in communication system. Then multiple choice question reference. Let us start. What is electromagnetic wave? Here, before going to explain electromagnetic wave, all of you must be remember what is communication system. Here you see this is the transmitting antenna. Here this is the receiver antenna. In order to communicate from transmitting antenna to receiving antenna, you can use two medium, either wireless medium or wire medium. In order to transmit the information in wireless medium, you use the radio signal. This radio signal is nothing but electromagnetic wave. Therefore, electromagnetic wave is the travel through many form of medium. However, the conductive media like metal form the barrier through which they do not travel. In some case, they can travel but are attenuated. If it is in conductive media, it unable to travel the electromagnetic wave. But in some of the media, it will be travel but attenuated. Attenuated means the power level or voltage level or the current level will be reduced to the desired value. The next is the electromagnetic wave has a two component. The radiations are made from electric and magnetic components that are inseparable. See, the electromagnetic wave have a two component, that is electric field as well as magnetic field. The plane of field are at right angle to each other to the direction in which waves is traveling. You can easily understand by looking the diagram. See, this is the electric field and this is magnetic field. If two electric and magnetic field are perpendicular to each other, the another direction is there, that is wave propagating direction, that also perpendicular to electric field as well as magnetic field. Here you see this diagram, you can easily understand. The electric component of the wave result from voltage seen that occur as the antenna element is edged by the alternating waveform. We know that in this electromagnetic wave consists of electric field. That electric field will be occur as the antenna element edged by alternating waveform. The other component that is magnetic field. The magnetic field is at right angle to electric field and held it is at right angle to the plane of the antenna. It is generated as a result of current flow in this antenna. We know that in this electromagnetic wave, the current is flow. If the current flow, you will get the magnetic field. The next is the electromagnetic wave. The radio signal can be reflected, refracted, and also undergo diffraction. This electromagnetic wave possible to reflect and diffraction and also possible to diffraction. Here you see the animation here how the electromagnetic wave is traveling. The electromagnetic wave travel in z direction. You see the red color it represents as a electric field that is due to voltage change as antenna element excite. Similarly, the blue color is nothing but magnetic field. The red color means electric field, blue color means magnetic field. Both electric field and magnetic field are perpendicular to each other. Perpendicular means exact right angle. The direction the next is the direction of wave propagation. We know that the wave is traveling in the direction of wave propagation. This is nothing but electromagnetic wave diagram. Another diagram is there. You can see this. It is also electromagnetic wave. Here it can be called as circularly polarized electromagnetic wave because it is in the round shape. So it is called as circularly polarized electromagnetic wave. Now I will try to cover what is electromagnetic spectrum. We know that see this is the electromagnetic spectrum diagram. Here you can see the radio, microwave, infrared, visible, ultraviolet, X-ray, gamma rays. See, the electromagnetic spectrum is the range of the frequency of electromagnetic radiation and their respective wavelength and photon energy. The electromagnetic spectrum is nothing but the radio wave, microwave, infrared, visible, ultraviolet, X-ray, gamma ray. This is nothing but a range of the frequency. For the radio wave, the frequency range is different. Similarly, for other wave, the range of the frequency is different. And also the respective wavelength. The entire electromagnetic spectrum from smallest to highest frequency include all wave that is radio wave, infrared radiation, visible light, ultraviolet radiation, X-ray and gamma rays. The electromagnetic wave in each of these bands have different characteristics such as how they are produced, how they interact with matter, their practical application. We know that different range of frequency is there. For the different range of frequency, their own characteristics. That is how they are produced, how they are interact with the matter, and also you have a different practical application for the different range of the frequency. Next, you see the Electromagnetic spectrum terms. The important electromagnetic spectrum terms is the frequency and the wavelength. In this case, what is frequency? The frequency is nothing but, according to standard definition, the number of repetition of the waves over particular period of time. It is called as frequency. The number of repetition of the wave over the particular period of time for given the time. Example 1 second. In that 1 second, how many repetition happen in that period? That is nothing but frequency. You can also another definition is number of cycles per second. The number of cycles per second is called as frequency. It is represented as small f. Mathematically, the f is equal to 1 over t, where f is the frequency of periodic wave, t is the time period at which wave repeat. The unit is hertz, abbreviated as Hz. Finally, the f is nothing but the number of cycles per second. You see in graphically here from year to year it has only 1 second. In this 1 second only one cycles are appeared. If it is one cycles of appear, then it can be represented as 1 hertz of frequency. If it is 1 hertz of frequency, what is the wavelength? Wavelength is given by lambda is equal to c over f. This is equals to 3 into 10 to the power of 8 divided by 1 hertz of frequency. Finally, it becomes 3 into 10 to the power of 5 kilometer. For the 1 hertz of frequency, the wavelength will be 3 into 10 to the power of 5 kilometers. If the frequency double, then what happens? Let us start. The frequency double means two cycles are there in 1 second. If it is two cycles are there in 1 second, then the lambda, that is wavelength, becomes 150 into 10 to the power of 3 kilometers. If it is one cycle, the wavelength is 3 into 10 to the power of 5 kilometers. If the frequency is double, then the wavelength becomes 150 into 10 to the power of 3 kilometers. In nothing but, if the frequency is increased, the wavelength will be reduced. If you increase again, that is 4 hertz of frequency. 4 hertz of frequency means 1, 2, 3, 4. 4 cycles are present. Then the lambda becomes 75 into 10 to the power of 3 kilometers. Similarly, if it is 8 hertz of frequency, 37.5 into 10 to the power of 3 kilometers. If it is 16, then 18.75 into 10 to the power of 3 kilometers. Again, increase the 32 hertz, the lambda becomes 9.375 into 10 to the power of 3 kilometers. Then it can be considered as, if the frequency is increased, the value of wavelength will be reduced. You can see the different frequency band and its wavelength. Different frequency band is given, that is VLF, LF, MF, HF, VHF, UHF, SHF, EHF, TH. The name is given for each frequency band, the separate frequency range. For the very low frequency, the frequency range from 3 to 30 kilohertz. In this case, the wavelength become 1 into 10 to the power of 8 to 10 into 10 to the power of 3. Similarly, for the very high frequency, the frequency range from 30 to 300 megahertz. The wavelength will be 1 into 10 to the power of 1 to 1 wavelength. Similarly, for the super high frequency 3 to 30 gigahertz, the wavelength will be zero point 0.1 to 0.01 meter. It is very important you need to remember the different frequency band name and also corresponding frequency range and wavelength. So many of competitive exams will ask these type of question. All of you must be keep in mind these frequency band and corresponding frequency range. Next. You see, the wavelength is long in the radio wave but gets shorter in the gamma ray. You can see this is the frequency. The starting the frequency is very low. If you increase the frequency, then what happens is that the wavelength become short, but here the wavelength become long. Therefore, in the radio wave, the wavelength is long, but in the gamma ray, the wavelength is short. Next, the radio wave. The radio wave is the electromagnetic spectrum in which having longest wavelength and smallest frequency. The application of radio wave is radio service, AM broadcasting, communication system, MRI. This is radio service, global positioning system GPS and MRI. MRI is mainly used in the hospital. Similarly, microwave. Microwave is the electromagnetic spectrum having the wavelength longer than infrared wave but shorter than radio wave and the frequency more than radio wave but less than infrared wave. The application of microwave frequencies are microwave O1, microwave communication system, radar system. Microwave O1 means your daily use the machine is the microwave oven and the radar system. The radar system is used to find the range to used to find the velocity of the object and also it is used to find the location of the object. The next is infrared wave. The infrared wave is the electromagnetic spectrum in which having the wavelength longer than visible light but shorter than microwave and the frequency more than microwave but less than the visible light. The application of infrared waves are TV remote controller that we are daily use. If you press any button from TV remote controller, it start pass the infrared wave from TV remote controller to the TV device. Then it will start operating. The next second application is the thermogram. In the thermogram nothing but the temperature can be calculated by amount of infrared radiation goes off. If we give the infrared radiation, the time means the temperature can be calculated. The next is the visible wave. In case of visible wave means visible light, it is the electromagnetic spectrum in which having the wavelength the longer than ultraviolet ray and but the shorter than infrared wave, and the frequency having more than infrared wave but less than the UV rays. We know that the longest wave in the visible is red light. You can see this image. Here is the longest wavelength, but here shortest wavelength. The longest wavelength, the color is the red. The shortest wavelength color is the purple or violet. Therefore, the longest wavelength in visible light is the red light. The shortest wavelength color is the violet light. You can see this animation when you passes the light onto the prism. Then what happens is that it start produce the what this type of light, this type of color. The start will be the red color, the last will be the violet color, and in between there are so many different colors. This is depending on different wavelength. If you change the wavelength of this particular white light, then what happens? It creates different colors. The next is ultraviolet ray. In case of ultraviolet, that is UV ray, it is the electromagnetic spectrum in which having the wavelength longer than X-ray but shorter than visible light, and the frequency more than visible light but less than the X-ray. It is possible to carry more energy than visible ray, and the mainly application is that it used to kill the bacteria, that is using sterilization of the equipment. You can see the bacteria. This can be killed by applying UV rays. When you apply the UV rays to any of the equipment, it kills the bacteria. It is mainly used in hospital. The next is the X-ray. The X-ray is the electromagnetic spectrum in which having the wavelength longer than gamma rays but shorter than UV ray, and the frequency more than UV ray but less than the gamma ray, and it is possible to carry more energy than ultraviolet rays compared to X-ray. Compared to what UV rays, the X-ray can carry more energy and can deeply penetrate the most matter. Here you see this diagram. This is nothing but X-ray. Here only you can appear the bones, and also you can appear the teeth. The bone or teeth absorb the X-ray, but rest of them will not absorb. Therefore, the X-ray can be used for making the medical image. The light part of the X-ray image indicate the light part means the white color light. The light part of the X-ray indicate the place where X-ray was absorbed. Means the light part will absorb the X-ray. The rest of the them will not absorb. The last one is gamma ray. The gamma ray is the electromagnetic spectrum in which having the shortest wavelength and eye gaze frequency. It can carry more energy than X-ray and can deeply penetrate most matter. It is widely used in the radiation treatment to kill cancer cell. Means it is widely used in hospital area for kill the cancer cell. Next, I will try to cover what is propagation, what are the different types of the wave propagation. The propagation nothing but sending the electromagnetic spectrum signal from transmitting antenna to the receiving antenna. There are different types of wave propagation, that is ground wave propagation, sky wave propagation, line of sight wave propagation. In case of ground wave propagation, the frequency up to 2 MHz can be propagated over the communication channel to the receiving antenna. Similarly, in case of sky wave propagation, the frequency range is 2 to 30 MHz. Then, the line of sight propagation, it, the frequency more than 30 MHz of wave propagation. The next is multiple choice question. The electric and magnetic field of the radio waves are perpendicular to each other, perpendicular to the direction of propagation, both A and B, none of the above. The electric field and magnetic field both should be perpendicular each other. Not only these two are perpendicular to each other, but also direction of propagation also be a perpendicular to these two fields. Therefore, the option A and option B the correct answer. The the answer for this question is option C. Second multiple choice question. The speed of the radio wave in free space is option A 3 into 10 to the power of 6 meter per second. Option B 3 into 10 to the power of 8 meter per second. Option C 3 into 10 to the power of 6 mile per second. Option D 3 into 10 to the power of 8 mile per second. Take your time and please answer. The answer is option B. The next is which of the following are electromagnetic? Radio wave, light, gamma wave, all of the above. Actually, light means your visible light. Radio waves is the electromagnetic wave. The visible light is the electromagnetic wave, and also gamma waves is the electromagnetic wave. Therefore, what is the answer? These three are the correct answer. Therefore, all of the above. Option D. The next question, what is the frequency range for ground wave propagation? Option A, less than 2 MHz of frequency. Option B, greater than 2 MHz of frequency. Option C, equals to 2 MHz of frequency. Option D, none of the above. The option is given only relevant to 2 MHz. For in case of ground wave propagation, the frequency up to 2 MHz can be propagated to the receiving antenna. So, the answer is greater than is not possible, equals to is not possible. Option A is the correct answer. If the frequency increase, the wavelength will be increase, decrease, remain same 1. ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಆದರೆ ವೇವ್ಲೆಂತ್ ಕಮ್ಮಿ ಆಗುತ್ತಾ ಜಾಸ್ತಿ ಆಗುತ್ತಾ ಅಷ್ಟೇ ಇರುತ್ತಾ ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಆದರೆ ವೇವ್ಲೆಂಟು ಕಮ್ಮಿ ಆಗಲೇಬೇಕು ಸೊ ಆಪ್ಷನ್ ಬಿ ಥ್ಯಾಂಕ್ ಯು